This question is about horizontal projectile motion, which I have taken from the May 21 paper 2 time zone 1 for HL and SL. So as you see, a ball is thrown with initial velocity of 12 meter per second, which we can say it's we can represent it with letter u, and you can also write ux, whereas you see that the ball is not thrown at any angle other than 0 degree, means that the ball is not thrown like this. So that's why we can say that the initial velocity along y-axis is 0 meter per second, which we will use later in SUVAD equations. So this is a parabolic path. This is a path that we know in always in absence of air resistance. So in this question, you have to find out the time taken for the ball to reach the surface. You have to prove it that this 0.2 seconds. So before we drive the equation for the time taken, let me clarify you that which component of motion should we use to drive the equation for the time. So for this, I'm taking this example. If we release a ball and we execute the one-dimensional motion of this ball such that its initial velocity is 0, we just releasing the ball, then the ball will follow this trajectory. It will go vertically downward. Whereas the ball that you have thrown with this velocity, how much, 12 meter per second, so it will follow this trajectory. Now remember that these two balls will reach the ground at the same time. The reason is their constant acceleration, the same acceleration at all the points. So I'm showing you these two balls are at the same levels at same instant of time. And what is the reason behind it? That is acceleration due to gravity is a constant value. It means that x component of motion is not significant, not important to calculate the time taken, because the important thing is the acceleration along the y-axis, that is equal to negative g. That's why when we will drive this equation for the time taken, we will assume the y component of motion. So we do not know what is the velocity of the ball at this point, the final velocity and its components. So that's why the only one equation that we have now that we should apply is this: S is equals to ut plus half at square. And I told you that we will convert it in for the y component of motion. So that's why I would write negative s, because the displacement covered vertically is negative 0.24 meter, is equals to uy into t plus 1 over 2 ay t square, that we can write negative s. What is a uy? You see that it's a 0, right? So we can make it 0 minus 1 over 2 gt square. So I have substituted the value for the acceleration, that is negative g. From here you can cancel this negative signs, and we got the, by moving the 2 to the other side, so 2s is equals to gt square, and we got t square is equals to. So what equation are we following here is this one, which you can always apply if the projectile motion is horizontal. Okay, projectile motion. So let's put the values. So you see I'm not writing negative sign right now because we had already considered when we were substituting the values, I mean like here. Okay, that's why. So the time value is 0.22 seconds. So this is a time when the ball will reach the table surface. Now in this next question we have to draw the vertical component of velocity of the ball versus the time graph. Okay, why vertical velocity? Because you know the horizontal velocity will remain same during this trajectory, during this process. Why is that? Because there is a no acceleration along x-axis. The reason is there is a no force along x-axis because we are saying that there is no air resistance. We are assuming this. That's why. Okay, now the how the vertical velocity. So we see that the vertical velocity in the beginning is 0. It means that with the passage of time, so in the start it is 0, but with the passage of time the vertical component of velocity will increase. So the magnitude will increase, and you can see the direction. is downward. Okay, and you can follow this equation, which also tells us that uy minus gt, but in this question they say take the value of g positive 10 meter per second square. That's why, and you know that initially it is 0, so v vertical velocity is equals to plus gt, right? Because of this question, right? So you can see that the vertical velocity will increase with the passage of time. And why it will? Because the vertical velocity is proportional to the time. So hypothetically we should get a straight line graph, a proportional line graph like this. But let's take the values. So let's check at the different time. For example, at the time t is equal to 0, the vertical velocity should be 0. I had already have written this equation. You can put the value in it. And for the next zero point 0.1 second, it should be, the vertical velocity should be equal to 10 into 0 0.1. So that should give us 1 meter per second. So let's draw the point. So that is exactly here. And in the same way, you can get another point at the at the 0 0.2 seconds. We will get this. So when we will join these 2 points, so you will get this graph, and you can find the gradient. Okay, you know that the gradient will also give you the acceleration along y-axis. So you can find the rise over run for this graph. So that should be equal to the 1 over 0 0.1. So that is 10 meter per second square. Now in the last question they are asking that will the ball will go over the net. So we have to decide it, and how we can determine that will the ball will go over the net. So we are given the height of the net. All right, and what is the height of the net? That is 15 centimeter, which means that it is 0.15 meter. So if you find the position of the ball at what time, at the time when the ball will reach the net, if you find the position of the ball, and if the height at that instant of time is more than 0.15, it means that the ball will go over the net. Now how do we know that at what instant of time the ball will reach the net? So we know the length of the table, that is 2.74 meter. So how much time the ball will take to cover the half of 2.74? So that should be 1.37 meters. So we can easily find, because we already know about the initial speed along x-axis. So you can apply suvat again, which equation now, but for the x component. So s is equals to ut, so uxt plus 1 over 2 axt square, right? You know that acceleration along x-axis is 0, and what is the displacement covered? That is 1.37 meters is equals to 12 meter per second into the time. So the time that I have calculated is 0.11 seconds up to these two significant figures. So at this time, what is the height of the ball? How can we find it? Now, what is the position of the ball? So I'm assuming, let's say this is a position of the ball. So if I apply this equation again, but now for the y component of the motion, why y component of motion? Because by with the help of this equation, s is equals to ut plus half at square. If you apply this equation for the y component, because for the x component we already know it's 1.37, so it's not need to apply that equation again. If you apply this equation for the y component, then you can find at what time, 0.11 second, how much is the displacement covered vertically downward. You can find out this displacement, and then you can subtract it from 0.24. Okay, so let's find it. So initial vertical component of velocity plus 1 over 2 into negative g into t square. You know that this is 0, and 1 over 2 into negative 9.8 into 0.11 square. Let's find the displacement. That should be negative value. Okay, so this is negative 0.06 meter, which means that 6 centimeter. It means that the ball has covered a negative 6 centimeter downward, or this distance is 6 centimeter vertical distance. So if we subtract it, then we can easily find out the position of the ball, which is how much? 0.24 minus by the way 24 centimeter minus 6 centimeter, that should be 18 centimeter. So it means that 18 centimeter is obviously more than 15 centimeter, which is the height of the net. So it means that the ball will obviously go over the net.